Okay, there are a series of questions we can answer. We can ask, what is the limiting reagent? What is the mass of precipitate formed? What are the concentration of all the ions after reaction? So we're going to start off now with the mass of the precipitate formed. Now before we do this, we have to calculate, we have to balance the equation, okay? So I'm going to start with balancing ions because this is a double displacement reaction. So instead of balancing the atoms, I'm going to balance the ions. And I'm going to choose sodium to start with because it's an odd number here and it's an even number here. So it's going to need a coefficient in front of both of them. So if I have 3 sodiums there and 2 there, 6 is they both divide into 6. So if I have 2 sodium phosphates and 3 sodium sulfates, I've balanced the sodium. Now I'm going to balance the counter ions of the sodium, okay? So I'm going to start over here with the sodium sulfate. I could have started over there. So I have 3 sulfates on this side. So I'm going to need 3 sulfates on this side. Now I balance the counter ion of the sulfate, which is the copper. I have 3 coppers this side, 3 coppers this side. Now I balance the counter ion of the copper. I have 2 phosphates here, and I have 2 phosphates here, and I'm back to the sodium. So I've now balanced every ion. Now the next thing I like to do is set up a structure to see what information I've been given. So what I need is these represent moles, but these are measured values. So I need to know how many moles of this I have. I need to know how many moles of this I have. And from this I can figure out what the limiting reagent is. Now, what am I given on the copper sulfate? Let's see, I'm given 10 grams, so I'm given the mass is equal to 10.0 grams. And I'm given, in order to calculate moles, I need the formula weight. So I go over to the periodic table and I calculate the formula weight of copper sulfate. And the formula weight is 159.61 grams per mole. And if I divide this into this, I'll get the number of moles. Now, for the sodium phosphate, I'm given a solution in a volume. So I need the molarity of the solution and the volume of the solution. The molarity is 0.100 molar. And I'm putting slashes through my zeros just in case there's an O up there, and I can recognize the difference between an O and a 0. Now the volume is 500 mils. Since molarity has the units of moles per liter, I'm going to save myself a step, and I'm just going to write the volume in units of liter. So 500 mils is 0.500 liters. Okay? Now, what else do I need to know? Well, what is the question? The question is the mass of the precipitate. So I want to know, and I often like to write what it is that I'm solving just to keep my eye on the target. What is the mass of the copper 2 phosphate? Now, in order to, from the stoichiometric step, I'll be able to calculate the moles from the equation. So in order to go to that mass, I need its formula weight. So the formula weight of the copper sulfate is 380.58 grams per mole. Okay? Now I'm ready to set up my equations. Now what I'm going to do is I'm going to set it out here and solve it, and then I'm going to show you the shorthand way to do it directly from the data given. Okay? So the first thing I need to do is calculate what is the limiting reagent. Now I'm going to go over here and I'm going to act as if the copper sulfate was the limiting reagent, and below here I'm going to act as if the sodium phosphate was the limiting reagent, okay? Now, if I have, how many moles of this do I have? I have 10 grams of CuSO4, and it has a molar mass of 159.61 grams per mole, and this would tell me how many moles of copper sulfate I have. Over here, I have a solution. So if I take the molarity, 0.100 moles per liter, and I multiply by the volume, which is 0.500 liters, my liters cancel and I have moles. Up here my grams cancel, I have moles. Now, what we do next is we do our mole-to-mole conversion using the equation for our equivalent statements. And when I do this, what I recognize is that what is in the numerator in both cases is the same thing. It's 1 mole of copper 2 sulfate. But what's in the denominator changes. So for the copper 2 sulfate, I have 3 moles of CuSO4. And I should have written up here CuSO4. And I should have written here Na3PO4 to identify what the substance was. Now, over here, I have 2 moles of PO4. Now, excuse me, Na3PO4. Now, at this step, I can calculate the limiting reagent. So if I take 10, divide by 159.6, I get 0.0627 moles. So the moles of this is 0.0627 moles. And if I divide by 3, I get 0.0209. So at this point, the number is 0.0209. Whatever number is the smallest is the limiting reagent. Now in this one, I take 0.1 and I multiply by 0.5 and I get 0.05. So the moles of this is 0.05 moles. And I should write moles here. N equals moles. And now if I divide this by 2, I get 0.025. So this means this is the limiting reagent because this is the smallest number. So then what I would do is I would multiply by the moles of the product that I want, okay? And since I'm after this, I would multiply by 1 mole of Cu3PO42. And then I would convert those moles to grams. So I would then multiply by the molar mass of this, 380.58 grams of Cu3PO42. And this would be grams per mole, its molar mass. And this gives me the mass of the copper phosphate that would be produced, which would be 7.95 grams. Now, I could have also multiplied this by the same 1 mole, Cu3PO42. And can we calculate the mass of this? And if I multiply that by 380.58 grams of Cu3PO42 per mole, then if I take this number here, 0.025, multiply by 380, I get 9.51 grams. Now, clearly this is the limiting reagent, but I multiplied at this point here, both sides by the same thing, So there was no reason to waste my time doing this, okay? And I simply would not have done that because I knew at this point in the equation. Now at this point, let's think about this for a second, okay? I could take out my calculator and I could take the mass of this, divide by the moles of this, the grams divided by the grams per mole, and calculate the moles. I could take the molarity of this times the volume of this and calculate the moles. Then I simply take this number, divide by 3, take this number, divide by 2, and whichever is the smallest number is the limiting reagent, okay? Then, once I identify which is the limiting reagent, I simply multiply by the moles of this and multiply by its formula weight. And I don't even have to set this all up. I think for students it's important to set this up initially, but once you've mastered this, if you write down what you're given below the species, you can do this much quicker than spending all this time to write it out. Okay, thank you. All right.